All right, let's look at one more example that has a little bit more going on. So in this one, I have a lot more factoring to do. First, I'm going to take a GCF out of the top and just factor the bottom, x plus 5, x plus 1. So the top is still a difference of squares, so let's factor that. X plus 3, x minus 3, over x plus 5, x plus 1. So now when I'm doing my domain restrictions, x cannot be negative 5, it can't be negative 1. So I'm going to draw a number line for this since we have a little bit more going on. So negative 5, negative 1, and it's like I have a hole right there where I can't equal. But I can equal everything else going on. So that means my domain is going to be negative infinity to negative 5, union, negative 5 to negative 1, union, negative 1 to infinity. Let's look at our end behavior and horizontal asymptotes. So once again, in this example, we have same degree in the numerator and denominator. So y equals the ratio of their leading coefficients, 2 over 1. So y equals 2. Does it cross the horizontal asymptote? So once again, horizontal asymptote equals my function. So my horizontal asymptote is 2. Set it equal to your original function. We call that the expanded form. It's just going to make your life happier. Okay, now this time I'm going to cross multiply and I'm going to go ahead and distribute this 2. So that would give me 2x squared plus 12x plus 10. You see I just distributed that 2 into everything. Okay, so when I subtract those 2x squares, they're going to cancel. So I get 12x plus 10 equals negative 18. Lost a negative there. So 12x equals negative 28. So x equals negative 28 over 12. And that would reduce to an x-coordinate. Everything's divisible by 4. So negative 7/3. And then the y-coordinate of that point is your horizontal asymptote, because we're asking, do I cross my horizontal asymptote? So that's going to happen at negative 7/3, 2. For an x-intercept, that means we set our numerator equal to 0. So 2 times x plus 3, x minus 3 equals 0. 2 doesn't equal 0. X plus 3 equals 0 if x equals negative 3. X minus 3 equals 0 when x equals positive 3. So my x-intercepts are 3, 0, negative 3, 0. Y-intercept means we substitute 0 in for x. So 2 times 0 squared minus 18 over 0 squared plus 6 times 0 plus 5. So I get negative 18 over 5. Write it as a point. 0, negative 18 over 5. Vertical asymptotes mean my denominator is 0. So x plus 5, x plus 1 equals 0. So x equals negative 5, x equals negative 1. I have 2 different vertical asymptotes. I have no removables because I didn't have any factors. Cancel. So I'm going to write a nice big sign chart over here because I have 4 things going on my sign chart because I have 2 x-intercepts and 2 vertical asymptotes. Now this is a number line. You need to make sure they're in order. So that would be negative 5, negative 3, negative 1, positive 3. Let's label what those are. So negative 5, negative 1 are vertical asymptotes, and then these are x-intercepts. And now I'm going to write a really, really big sign chart. Okay, so I'm writing it from my factored form because I have a lot going on in this one. So I have 2 times x plus 3, x minus 3, x plus 5, x plus 1. Now, for 2, do I have any variables going on? No. So this is just going to be positive, because it's always a positive 2. So does this line really matter? No. But if that was a negative 2, it'd be really important that I had that going on. So I just always put it just to be careful. So let's look at the next one. So I have x plus 3 that critical value is at -3. So everything to the left minus everything to the right plus. X minus 3, that has a critical value at +3. Minus, 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 plus. X plus 5 has a critical value at -5. Negative to the left, positive to the right. And +1, minus, 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 plus, plus. Okay, so remember, when we're doing negatives, an odd number of negatives will make it negative, an even number will make it positive. So that means this first column is going to be positive, then it's going to be negative, positive, negative, positive. Now, these have been alternating. Is it true that they always alternate? Absolutely not. So you cannot rely on these alternating. Is just not always going to be true. So let's do our vertical asymptote analysis. So I'm going to start with -5. So I'm looking right here. Limit as x approaches -5 from the left. To the left of that is positive, so positive infinity. Limit as x approaches -5 from the right. To the right of that is negative infinity. Now I'm going to look at the -1, so that's looking here. Limit as x approaches -1 from the left. To the left of -1 is positive. Limit as x approaches -1 from the right is negative infinity. Look at those great infinities. All right, so we're ready to sketch. So on here, let's do our y-intercept, or our horizontal asymptote, sorry. We'll get to our y-intercept. Horizontal asymptote at y equals 2. We have multiple vertical ones, so we have a vertical at -5. We have another vertical at -1. We have some x-intercepts, so I have an x-intercept at 3, 0, -3, 0. I have a y-intercept at 0, -18/5. -18/5 is going to be a little bigger than 3, so we'll go there. And this time I also have that we're going to cross our horizontal asymptote. So we're crossing at -7/3, 2. So that would be about there. Anything else? Nope. So let's add our limit analysis information. So left of -5 is going to go to positive infinity. To the right of -5 is going down. Left of -1 is going up. Right of -5 is going down. And we'll use our sign chart to finish everything. So left of -5, everything is positive. So I already have this nice arrow. We're not crossing anywhere over there. We already have our point where it crosses. Between -5 and -3 is negative. So something like that. Then between -3 and -1, it's positive. So I'll just go through that point we know is going to cross. Between -1 and 3 is negative. And then after that, it's positive, but we're going to level off at our horizontal asymptote. And we're done.